okay with that. So today with us, we have the PLEES team. Firstly is Tadeja Veršič, who is a PhD student in astrophysics studying the structure of dark matter halos of galaxies. And recently her passion lies in leveraging her experience in statistics and programming to contribute to the fight against human-induced climate change. Gwenaël van Looveren is a PhD student in astrophysics. His research is focusing on rocky exoplanet atmospheres and the influence of the host star in these atmospheres and how they evolve. This research has emphasized just how special and fragile our Earth is, according to his view, which is true. And this led him to join this team to make the effects and impacts of climate change more easy to understand. And Laurane Fréour is a PhD student in astrophysics as well, who focuses on the formation of multiple stellar populations in globular clusters. She's actively involved in addressing climate and social issues through various projects, such as the PLEES Index, and developing a course on sustainability in academia. Additionally, she volunteers with NGOs, including the Climate Fresk, the Astronomers for Planet Earth, and recently also our Lectures Without Borders. So we're happy to have all of you here today, and the floor is yours.
Sorry, I was muted. Thank you very much, Natia, for the very nice introduction. And I hope that you can see my screen now. Yes, okay.
Yes, we can see it.
So I'll try to make it full mode, but it seems that it's not, well, I guess it's also fine this way. So yes, we are very happy to be here today. Thank you for the invitation. And we are going to introduce to you the PLEES Index, which is a project that we have been working on from our PhD during the last couple of years. And we try to reflect on ways to communicate on climate change, to try to trigger action to act. And without waiting more, I will ask you to join us with a quiz. So there will be 3 questions, and you can join either by scanning the QR code on the screen or also at slido.com. The 3 questions will be separated by some talk, some discussion. So please just also keep the window open so that you can keep answering questions until the end of the quiz. So far, I see that no one has been able to join yet, so maybe we can wait a bit more. Is the quiz active? Because it's not showing in my screen. Ah, 1 participant is typing. Okay, perfect.
Yes, now it's active. Now it is active.
Perfect. So yeah, the first question that we wanted to ask you is what word comes to your mind when talking about climate change? And you will see appearing on the screen some words. So we see first unavoidable, okay, challenge, action, education. Action is coming bigger because more people are putting this word, are writing this word, awareness, rapid, emergency. Okay, thank you. So you might also be familiar with this figure from the IPCC report 2023. So the IPCC is the Intergovernmental Panel on Climate Change. And on this figure, you can see the extent to which current and future generations will experience a hotter and different world. And you can see a timeline from 1900 to 2100, and it is colored according to the global temperature change with respect to pre-industrial area. And if we take a kid born in 2020, for instance, during their lifetime, they will experience a global change in temperature going from around 1 degree, which is now, until +4 degrees, depending on the emission scenarios. So that's quite a huge difference. And sometimes it's a bit hard to understand for ourselves, what does this change in temperature actually mean? And that's one of the questions that we try to tackle with our project. And another one, which is linked to this also headline statement from the IPCC report, there is a rapidly closing window of opportunity to secure a livable and sustainable future for all. So the climate is changing, temperature is changing very fast, but can society and how can society actually change also fast in order to avoid this unavoidable, as someone said before, change in the climate. So this leads us to the second question of the quiz today. Are you familiar with the concept of social tipping point? We'll give you a few tens of seconds to answer this.
It mentions here that the voting is closed. Is it possible we need to?
That's weird. Okay. Let me check what I can do. Maybe I can try to re-present with Slido, because it seems also that the full screen mode is not working. Can you try again to join now? Maybe it's working better, I hope.
It still says voting closed. I'm wondering if you have to. I think you can. Yes, now it's open. No, now it's closed again.
Okay. And now,
yes,
what about now?
Now it is open.
Okay, perfect.
Thank you.
Okay, so it seems that at least 2/3 of you are actually familiar with this notion or have heard the notion, so that's very nice. And to give you, maybe just so that we are all on the same page, a definition of this tipping point. So it has been defined by Malcolm Gladwell to be that magic moment when an idea, trend, or social behavior crosses a threshold, tips, and spreads like wildfire. So it's a moment where change can happen very, very fast with respect to the previous inertia. And it has been actually linked to several studies. They have shown that social tipping dynamics, for instance, would be a very efficient way to stabilize Earth's climate, so to act against climate change. And to give you a bit more also of maybe an understanding, here you can see the pace of social change in the United States. So you have the timeline in the x-axis from 1787 to 2015, and in the y-axis there are the number of states that have removed a ban. And for instance, if I take this orange curve, which shows removing of ban on prohibition, we can see that during almost 50 years from 1850 to 1900, there is nothing much which is happening. It's quite stable with some variations. But then suddenly, in around 1910, in 10 years, more than 20 states have actually removed the ban on prohibition, which means that change can happen and has happened very fast from this time. And this is the idea of social tipping point. And now we have the last question for you. I hope it will work and it's not closed again. Have you heard about Maslow's hierarchy of needs? I'll give 10 seconds to answer, because I think if I'm going to the next slide, and it's closing the vote from what I understood. Okay, so it seems that 1/3 only is very familiar with this hierarchy of needs, and the rest of you is not. So we are going to introduce this concept now so that we are all at the same page also. So Maslow in 1943 explained his theory that individuals are motivated to fulfill basic needs, like for instance, eating, drinking, having a shelter, rest, before progressing to higher level needs. So before developing higher level needs, for instance, the need of friendship, relationship, and then also esteem needs, which are more maybe individual based, like feeling of accomplishment and self-fulfillment needs. So basically the idea of this pyramid, of this hierarchy of needs, is that each level is building upon the previous one. And Maslow himself didn't plotted it as a pyramid, but that's a current representation because it's very visual. And then this leads us to our idea, which is building up the PLEES pyramid. And so the idea behind this was really to try to communicate on climate change based on notions that the public in general might be familiar with. So for instance, the theory of Maslow. And so we are going to guide you through how we build up our index. And the first part is the baseline of the pyramid, like in Maslow's theory. And the first index is P, which stands for poverty. So our idea was to equate physiological needs, need to eat, drink, to poverty. And poverty correlates with droughts. So in our first index, which range from 0 to 1, 0 represents high vulnerability to hunger, while 1 is low vulnerability to hunger. And now we're going to show you some equations, but please don't be afraid. We're going to guide you through all of them. The first equation, which is for the P index, is so I represent here a country. So each index is computed at the level of a country. And P is divided into 3 components: the exposure, the sensitivity, and the adaptive capacity. The exposure is correlated to the consecutive dry days, so the droughts. The sensitivity is correlated to cereal crop production, and the adaptive capacity is correlated to the poverty rate, because the poorest is a country, the more complicated it is to adapt and to react to climate phenomena, and the more and to react to hunger in general. So our equations here are based on work by Krishnamurthy et al. 2014 and Richardson et al. 2018.
So in the second step of our pyramid, we have the life expectancy, the LE in PLEES. This index we've correlated to the safety needs in Maslow's pyramid. This can be correlated to the to heat waves, because there is indeed, if there's more heat waves, people tend to suffer from all sorts of ailments, such as heat strokes, dehydration, certain problems, which cause a reduction in the life expectancy. This index has also been rescaled between 0, which would coincide with a 10-year reduction of the life expectancy due to heat waves, and 1, the best value, where there's no effect from heat waves. When we look at the more detailed equations, we can see that this LE index is again defined per country, and it is calculated by taking the difference of a base life expectancy, which just takes the normal mortality rate into account to calculate life expectancy. But we then look at how much shorter the life expectancy is due to extreme weather-related events, or in our case, extreme heat days. For this life expectancy, we add an extra term, an mortality excess, so excess mortality, which is dependent on the amount of heat days and how vulnerable a certain country is to extreme heat. These equations have been based on work by Fréour et al. From 2017 and Hauer and Santos Lozada. This then leads us to our third index, the E index. This stands for employment rate, and this is related to the needs to belong in Maslow's pyramid. We can relate this to heat and humidity. That's our climate indicator. And this, in our everyday life, this would be how the primary sector is influenced, or the productivity of the primary sector is influenced. So these are professions such as agriculture, fishery, construction. When our value is low, we'll have low productivity, and when it's high, we have a higher productivity. When we look at the exact equation for this index, we see that we have a first term, which is related to the hours lost in our primary sector. And this is scaled to the total work hours in a year. And then we have a second term, which is related to the unemployment rate of a country under different scenarios. The inspiration for this equation and this index has come from work by Parson et al. From 2021. last step in our pyramid is the S index. And so now we have the full PLEES index. And this has been related to the esteem needs. Our S stands for satisfaction with life. So what is life satisfaction of a person in a given situation and in a given country? This has been correlated to the climate change or the climatic variable degree months. I will get back to that one in a bit, but the simple understanding of it is a value of 0 means that there is the low satisfaction in a country, whereas high satisfaction coincides with 1. If we look at the exact equation, we've seen that in order to scale it between 0 and 1, we had to look at how does the life satisfaction compare to the global life satisfaction. But each individual life satisfaction can be calculated with this longer equation, where we have our first term, which depends on the gross domestic product per capita. So the more wealthy a country is, the generally more happy people are. So there's this positive correlation. And that is followed by a second term with the negative correlation gamma, which depends on the degree months. And these are the number of months that differ significantly from a baseline temperature. This is the kind of temperature which is considered to be pleasant for people. If it's too hot, then, well, people start getting annoyed. And if it's too cold, we have to start heating our homes to feel more comfortable again. And these equations, especially the long one, has been inspired by work from Madison and Verdans, 2011. And so with these 4 indices, which all are values between 0 and 1, we can get our final PLEES index, which becomes a number between 0 and 4.
So now that we understand the mapping between the Maslow's pyramid of needs and how we linked it to climatic variables, we can have a look a bit at the results. Because if you remember, one of our goals was to make it easy and to make it easy accessible, the numbers that we see, the temperature variations that are projected under current greenhouse gas emissions, and link that with a variable that people will find it easier to relate to. And one of the key components that we've already mentioned throughout this presentation, that this is computed. We compute this for each individual country. So that's why it's the PLEES map, and we will show you how we will give you some flavor of what our results are, and then also show you how you can explore that for yourself, for your own region. So before that, let's go back a bit to this plot that was already shown by Laurane. And what we see here is the temperature changes, how the temperature has been changing and how it is expected to change depending on the different emission scenarios. So this very low, intermediate, and high. And what we have computed actually is we have computed the individual PLEES index, PLEES indices, and then the cumulative one at given time step, depending on the availability of the data. And now let's have a look at a family, and let's have a look at what kind of a life the grandparents had. What would they see? How the world would look like through this PLEES index in 1975. And what we've computed is the value of this index for different countries in the world, of course, depending on the available data. And what you will see here, the lighter the color, the higher the value of this index, the more satisfied generally people are, higher employment rate, etc. And the darker shades correspond to the lower value of PLEES index, where people are still less satisfied with life and are more pursuing lower needs, analogous, more in an analogous way, lower needs on the Maslow pyramid of needs. And you can see here maybe some general trends with more developed countries like Europe, US, having a higher value of these bliss index, as one would expect, and the countries more in development of the African continent, the Indian subcontinent, having lower value of the PLEES index. So this is kind of how how the world would look like through this PLEES index for the grandparents. And now let's have a look in 2010. Let's fast forward to how the parents of such a family would see the world through this PLEES index. So now we see maybe a bit more countries, and if you remember a bit, maybe some of them, especially European countries, look a bit lighter, and some African countries look also a bit lighter color than what was in 1975. But we will show you the difference so that you don't have to remember. But now the interesting part comes in the next slide. We can project it through available data, through available projections of the temperature changes, through the climate change projections. We can compare how the kids of such a family, how they will see it. And for that, we choose two different timestamps in 2050 and 2080. And we chose to compare two different scenarios. One is this RCP 4.5, which is this intermediate emission scenario under which the temperature at the turn of the century is expected to rise between 2 to 3 degrees compared with the baseline level. The RCP 8.5, that is a much more sinister scenario where the temperature rises at 4 and above degrees over the past century, where like we make minimal attempts to curb emissions. So let's have a look. First, under this intermediate scenario, RCP 4.5, how will these generations of 3 different generations see the world change? And you can now see in this animation how from 1975 to 2010 the PLEES index does increase, but when we go to 2050, 2080, actually throughout the globe in countries the PLEES index decreases. So the people's needs become less satisfied. The poverty index reduces, and the life satisfaction reduces, life expectancy, and all the and different indices that make up this PLEES index. So it's not so easy maybe to see on such a map what the stark change that we will see. Because of the excess emissions, what we can have a look at is in the 4 decades from 2010 to 2050, what will be the difference in the PLEES index. And here I will compare 2 different scenarios, but let's have a look at this one first. So under this RCP 4.5 scenario that is still hopefully realistic, we see in orange and red shades that most of the countries will actually experience, as we saw maybe a hint before, will experience a drop. And this will not spare any country, and even developed European countries, for example, will experience quite a drop in the quality of life. This means that analogously, in 2010, the peak of people's needs being satisfied has already been reached, and from now, like, our quality of life will be decreasing, which is unfortunate because we hope that with each generation we will see an increase. What is even more worrisome is when we look at the RCP 8.5, when we compare this, when we compare the 2 different scenarios, then you already see very visually that that under this increased excess emission, where even more CO2 is continuously being dumped, where no policies are being put in place to curb the CO2 emissions, the PLEES index will drop even more substantially. There are some exceptions where, because of because of increased heat in cold countries such as Russia, Mongolia, and Nepal. People won't have to heat up their houses too much, but actually this trend, we will see that this trend actually changes and gets inverted when we compare 2050 and 2080. So this is why maybe it looks like in present day Russia and Mongolia, it looks like the situation is improving, but that is a short-lived phenomenon. But you can see here what we wanted to emphasize, the stark difference in between these two scenarios as close as in 2050. So now that we've understand a bit how globally the cumulative PLEES index looks like, what we can do also is have a look at the individual PLEES indices, and for that we've elected to show you Europe. We are all European based, so that's why this region in particular is close to our heart, and we want to show you here which aspects of the PLEES index, which aspects of our lives will be most impacted, because through the PLEES index you can explore whether more the lower level of the pyramid will be impacted or more the higher. So now we can have a look at this under RCP 4.5, the difference in the PLEES index between 2050 and 2010 values, and the PLEES index that the individual indices that are actually that will see the largest change are the P index. So the poverty index will so to say increase because of the excess heat days. The food insecurity will rise because of the consecutive droughts. Another index that will be strongly that we found will see strong changes is this S index, the satisfaction with life index. And here we already see some of the trends that I've also mentioned, namely that the northern countries will see a bit of an increase in the life satisfaction because of the warming climate. But most of the Europe, especially Western, Southern Europe, will see a decrease in the satisfaction with life, partially due to increased heat that will reduce the satisfaction with life, as we showed you before. But this is not all. What is even more worrisome and what can be explored with this PLEES index is that this change in the PLEES index will actually accelerate. So if we look at 3 decades, the difference between the PLEES index under this RCP 4.5 scenario between 2080 and 2050, this is a shorter decay, the shorter time step that we've shown you before, and you already see much darker shades of red, which means that the PLEES index will decrease even more, and this change will accelerate. So it will not be linear, but the change in the life satisfaction in the employment rate will accelerate. And that's now you see on the top left panel, the S index. You can start seeing this trend where the countries that were green before are now seeing lighter shades of green and negative trends. As I said, this trend is short-lived. So this is something that you can we will explore some of the basic trends that we've seen in the PLEES index. And I will leave it with Gwenaël to tell you a bit how you can explore your own country and see for yourself how your life, your children's life will change in the near future.
Yes, so indeed here we've gotten just a little taste of all of the data, but of course the world is a large place. There's a lot of countries that you could have a look at in a lot of different scenarios or time steps. So if you're interested to explore it a bit more on your own, or maybe use it as a tool for explanations to others, we've prepared a website which you can find through this QR code or the link provided at the bottom, which has an interactive map where you can look at the different scenarios, the different countries, and to see how different indices change over time. with this, we want to thank you for your attention, and we hope that you have had that you found this interesting and that you have questions or comments, maybe remarks on our work that we'd be more than happy to hear and to discuss with you.
Thank you, Gwenaël. Thanks everyone actually for your nice presentation. We can have questions actually from anyone who would like to unmute or write it in the chat. It's just raise your hand or just let me know and I will unmute you immediately. Now, actually, until there are some questions in the chat, I have one question. So when it comes to comparing the first something like 40 years, right, between 2010 and 2050 and the next 30 years, there is this, at least in Europe, there is this opposing trend between the two, let's say, west and east parts of Europe. And also, like, this is kind of dividing from north to south. So it either concerns Scandinavian countries down to the Balkans and to the east. So do you expect some more, let's say, conflict in finding basically common climate routes? Since half of the population is going to be experiencing an increase in the life satisfaction and half of the rest. This is an interesting phenomenon. Actually, it's a very interesting insight. So I wanted to ask your opinion on that.
That is actually a very interesting question, and something that I haven't thought about. I will ask my colleagues if they have any questions. Otherwise, I have some thoughts on this.
Go for it.
So I think that, yeah, in particular, the satisfaction with life is a very complex index altogether. And I think that your question underpins the problems with addressing climate change actions or making climate change actions, that it has to be taken with great care. And it's not one shoe fits all, but you have to be very careful. Different regions will have different needs. One of the interesting things, I mean, with this satisfaction with life, there are some basic properties that we've shown it correlates strongly with gross domestic product, as well as the degree months. So there will be, of course, as the country gets more developed, it will have more satisfaction with life, but then it will have to put more of that money into climate mitigation. That's why we see then an opposite trend in the next decade. But it will, I mean, this can definitely, I think that looking at these all indices together will help us find where areas where different countries will be impacted and how to then propose local changes. But yeah, I think there's no one shoe fits all.
I see.
I hope this answers your question.
Yeah, no, for sure. It helps a lot. Thank you. And I have one more question that's basically I missed a part there. I see actually there is a question from the crowd, so I will save my question for later. Please, Beniamino.
Hello. Thank you very much. This is very, very interesting, and I think it's a very nice visual to give some extra information that is not just a usual narrative, especially the fact that you can like show how the individual components of the index change, and they don't change the same way. And actually, I was wondering if you have looked or thought of actually also how these different parts of the index relate to different parts of the population. What I mean is, for instance, if the index that is related more to drought, and you related it also with poverty, if I am not wrong, and this is related also to the food production, then I'm guessing the people that are involved directly in the food production will also have a loss, like an economic loss. So for them, it's also a difference in the satisfaction part of the index, so they have a different impact from a person says as work in education or in the tertiary system. So it can really, maybe it can really work on exploring different parts of how different parts of the world and different populations are affected.
Yes,
And
thank you.
I have a second question that it's a smaller question, and it's if you can expand a bit on how the degree month changes throughout the map, like because you said it's related to a base index, and if you could elaborate a little bit on that, or otherwise I can just go check the source. Thank you very much.
Tadeja, do you want to?
Laurane, maybe because this degree months question is a bit more very specific and we can address it later and it's a bit easier, I think. Maybe you can address the first part of the question if that is okay. But
Yes.
Sure. I mean, the details we can also leave for the end of the discussion if there is nothing else.
But yeah, for the first part of your question, it's very interesting because indeed there is like, of course, people that will be directly impacted, as you said, with this P index. So for instance, working with crop production and agriculture in general, they will be less able to work also through the E index. And therefore the life satisfaction will also decrease from a personal point of view. But this is also where this index, it's very like this PLEES index is very complicated because there are a lot of, it's not linear and there are a lot of feedback loop in a sense. So here we really try to focus on the most, the climate phenomena or social phenomena with the highest correlation, but there are actually a lot of smaller correlations that we hope to further explore later on with this project. And there is also like another thing that we thought about is migrations, because there will be a lot of migration also, which can then have a future impact on many other parts of life.
Yes. Thank you.
Yeah, but definitely this subgrid, this kind of like a subgrid analysis on which sectors in particular will be impacted is will be very interesting, but one would need a very specific science question, like which science question you want to address, then could be like how it will impact wheat farmers, for example. And I think it would be very, very interesting, and maybe on some like localized regions of the world, it could be done depending on the availability of the data. But this is definitely something that could be very interesting, especially if you want to use this kind of tool to inform policy, to actually inform policy and also drive policy.
Yes. And I think also the other way around can be done. Like if you have in mind a specific action that can be derived from a policy that it's doing good, you can see how it propagates at the different levels.
Last point that I'd like to add to this one is that you're of course correct in everything that's been said so far, that there's a very big difference on who gets impacted how much, but we've tried to keep them as general as possible to find sort of the factors that would influence the population as a whole, because of course if crop production goes down, then some people will be more affected than others if prices go up, but generally it is something that would influence the whole population. Similar, if the construction sector cannot work, well then roads might not be maintained anymore, which again influences the productivity of other sectors as well. And so that's with each index we've tried to keep it as general as possible, but indeed a deeper dive would definitely be interesting.
It's a connected world after all, so you're right.
Absolutely. And to your question on the degree months, if there are no other immediate questions, I can address it.
Yes, actually it was mine as well. So please go ahead.
Okay, excellent. So this degree months, we also took this degree months based on the literature studies that have found this baseline temperature to be quite stable. And what this effectively is, it looks at the mean temperature each month and looks at how it deviates from this baseline temperature. The rationale behind this is if the mean temperature is higher than the baseline temperature, you have to cool your place to feel satisfied, to feel comfortable indoors. I think we've all experienced, especially now in like very hot summers, that you need AC, something, because when it's more than 30 degrees, you just die. And you really need, in order to feel productive, to be productive, to go about your day normally, you have to cool the indoors, because we spend a lot of our times indoors as well. And if it's below 18.3, then you have to heat your house. So the difference between how much you have to cool or heat your house per month on average, that is what will determine this degree month. So it is a positive deviation from this baseline temperature. And then you sum it over the whole year. And then you see like countries, for example, countries that have large variations in the yearly temperatures, have really cold winters, really hot summers, will have very high value of this degree months. And the way we've computed it is cooling and heating degree days, which are two components of this degree months, are given by the IPCC report, and we averaged it over the whole country. So this is how we've computed this value.
Interesting.
Yeah,
Actually,
very clear.
Yes, it could be that you have feedback based on the poverty, coming back to how much you have to spend for all this extra energy. This could be, it's a really non-linear index, right? It has a lot of
Absolutely. Absolutely. Yeah.
But we have one more question, actually. So it's from Mikita. Please, Mikita, you can unmute yourself and ask your question.
Thanks a lot for your presentation, and I can say not mainstream way to connect satisfaction of life and climate change. So it's really something new to me, and thanks for your work. But I not know if this question, but maybe objection will be about how you averaging some countries. My objection based on that, yeah, Europe, it can be a good example for what you are showing, because countries are small, and for example, changing in temperature will be the same for the whole country, because, yeah, as I said, countries are very small, people are distributed very constantly, I can say. I know that there will be some examples which are not, but for example, Russia, which is a very big country, and changing in temperature will be not the same for the whole countries. For example, some north regions will be affected more than some south regions. And what else I can add here, that distribution of Russian population is also not the same. Maybe the people who lived in the southeast area, which will be affected more. I think that which will be affected more. So the satisfactory index, which is based on average temperature, will be decreased so much. So my point is, when you, for example, show Europe, where the whole Europe become more or less orange or even red, the Russia from Kaliningrad is not much here, for example, because I think that it should behave the same as Poland and Lithuania, for example, and the Moscow region or some closest to the Europe should also behave the same, because the most of the population Russian lived in the Moscow region, for example. It should behave the same as all bordering countries like Baltic states or Belarus or Ukraine. What do you think about it?
Yeah,
If
that's
it's okay.
definitely. Oh, sorry.
Yeah, if it's okay with Laurane and Tadeja, I can answer this question. The very short and easy answer is lack of data. So because of a lot of our indices are based on some sort of vulnerability, that means that we need data on, for example, distribution of population within a country, or for example, what is the mortality rate on a region level. And unfortunately, as you can see from the world map earlier, we're already missing a lot of this data in general for countries as a whole. So getting this data down to like region level is often actually missing or not publicly available. So all of the data we've collected here were from open databases, but there are plenty of countries that do not just readily share this data or do not even keep census of or something like that. So that's why we've had to unfortunately settle for a lot of these big agglomerated regions like all of Russia or all of Canada, even though we are indeed quite aware that there are differences. And some places do provide more detailed data. The United States, for example, and I believe Brazil do have much finer resolutions of their data that we could find. But yes, if you know of other data sources where we could get this information, that would be great. But we've not been able to find them yet.
Temperature distribution, or how temperature will behave. There are some models
Yes, the
which
temperature,
will predict. And the density of population, it also, I think that is not some, some hidden data which is not available to find. I do not know because I do not use this data. I can speak about temperature because I use it in my research. But density of population, I do not think that is some not available data in internet. And even the progress of density, so how it's changing during the time. Which maybe you are experts on it. I'm only who ask the questions. Thanks.
Thank you, Mikita, for your question. And actually, with the discussion, I came to another question myself. Since you are using an index that uses a lot of data and then you have to make a value for all, you are compromised by the coarser resolution, the dataset with the coarser resolution. Is that correct? Okay, and that's the one of the GDP, for example, per country. Is it the one with the coarsest resolution, or it's a different one?
So the GDP is one that is somewhat coarse. There is the vulnerability to heat is also a somewhat difficult one because the category of mortality due to extreme weather events is very, very limited in data that it provides, because this is not a standardly registered cause of death in most countries. So for the life index, the life expectancy index, it's also very, very difficult. I don't know if Tadeja or Laurane know of others that might cause problems.
Yes, for as you said, the population, because this World Bank provides and the different shared social pathways that are provided are mainly providing the gross domestic product and the population, but not per region, but per country. That's why it's also not so easy when we look at the historic data, where some countries didn't exist, like Yugoslavia was still there in 1975, and then we have to kind of like map this. That is also not straightforward. So we are to a large degree limited by this gross domestic product, for example, that doesn't provide. Maybe this is something that Nikita suggested might be interesting to weigh it based on the density of the population, to weigh each of our index just straightforward. Maybe this is something that we can directly take a look into. But as Gwenaël, I think, very nicely pointed out, that will also be a bit more difficult to map to vulnerability due to heat, for example. When you have countries, for example, like Australia, where the south is much more prone to the heat than the north, to heat waves, how do you then weigh more excess mortality due to heat in such a country. So you always have to do some kind of averaging, and when we try to do the best that we can. But I think that the suggestion by Mikita, I think it's a good one that we can try.
Yes, actually, I don't know if you know of the dataset of the world settlement footprint between the European Space Agency and the DLR. I know they're working on it. I don't know if the dataset is public yet, but they're working on basically settlements, like mapping cities and populations around the world. So this could be one way out of at least one of the issues for the court resolution.
Nice, thank you. Yeah, we'll have a look at this.
Yes, I can also try to find some information myself and send you. Okay, I don't think we have any more questions from the public.
I have one, if there is time.
Sure.
It's not so much a question for debate, but it's like, because the link that was sent in the chat to access the platform, which is really cool, does it also have like some way of using it in an interactive way? Let's say you are in a classroom and you want to show them what happens if their own country does something about climate change and improves some of the indices. Is it possible to access the code to run it dynamically or something like that, since it's on GitHub? Or it's only the interface that is accessible?
For now?
Yes, Gwenaël, he did all the work for the website, so if you want to answer this, maybe.
Well, at the moment, we just have the interactable map. If I manage to actually get back to the page, but so yeah, this can be used if I'm trying to open it so I can show. Okay, so here we see, for example, the map, and what could be used in classes is to look at different countries. So here, for example, when I go over Brazil, it will tell me the different indices. So for what the P index is, the L, E, the E, and the S, and it will give me some more information on how it compares to the different continents. Then I could also change my map to show different indices if we want to focus on one of them, and then also on the different scenarios where we have the past, the present, and then two different future scenarios. So at the moment, it is still limited to these cases, but we do hope to, once we manage to clean up more things, or if there are certain suggestions, we're more than happy to add to it. Currently, the code is not publicly available, but this is, correct me if I'm wrong, I'm looking at my co-speakers. We do plan on releasing them at some point also as part of this website, because it is indeed a GitHub website.
Okay, thanks. It's actually very pleasant also, the colors. I like it a lot.
Okay, I think we don't have now more questions. So we reached also our time plan, so pretty good job, everyone. Thank you for presenting to us today. And yes, we hope to see you soon in one of our next webinars.
Thank you all.
Thank you very much.
Thank you,
Bye.
and thank you for the interesting discussion. Bye.
Bye, everyone.
Have a nice day.
Bye.